Hi calculus students, we're here doing the fundamental theorem of calculus, looking at a function g of x, and it ends up being an integral function of the function f of t dt measured from 2 to x. And here we're trying to find g prime of 4. So what we need to recall is the fundamental theorem part 1 that says if we take the derivative of an integral in this format, that we're going to get f of x. So in this case, we're going to write down the following. We're going to write down g prime of x. And that means we're going to be taking the derivative, right, d dx, of our equation. And here we have d dx of the right-hand side. And this ends up being just f of x. So recall, if we're trying to find g prime 4, that would be equivalent to finding f of 4. And we can find f of 4 by looking at the graph, because we have a function of f. So f of 4, so we have then here, and we're here at a height of 2. So g prime of 4 is equal to 2. And in the second part of this same function, we're trying to find out on what intervals is g of x concave up. So what we have to do is make sure that we're not looking at the function f of t and looking where it's concave up. That would be a mistake. So what we want to do is, let's talk about what g of x being concave up means. Concave up is when your second derivative of g would be positive. So that what we're going to look for is taking the g prime function that we did in the first problem, which we know is then just f of x based on the fundamental theorem, and then we're taking the second derivative. So g double prime would equal then the derivative of f, or f prime, and we need this f prime to be greater than 0, because that's when we want to be looking at, because that's when g is going to be concave up. So when is f prime greater than 0? So when's the slopes of f positive? So my slopes of f are positive, so we're going to have between 0 and 2, and we're unioning that with, and then my slopes here, right, are going to be negative, and here they're going to be positive. So then we also have between 4 and 6. And then between 6 and 10, the graph is concave down. So on what intervals is g of x concave up? Well, between 0 and 2, union with 4 and 6. In this part of the problem, we're looking to find the tangent line to g of x at x equals 1. So in order to do so, recall that we simply need g of 1, or that's the function value, and we also need g prime of 1, which is then going to be my slope. We can do g prime of 1 probably easier, so g prime of 1 would be the same thing as f of 1. And f of 1 based on the graph is up here at a height of 2. So I have a height of 2. Then what we want to do is we actually want to find g of 1. Now g of 1 is defined based on the integral from 2 to 1 of f of t dt. Now, we're probably best to write this as the negative from 1 to 2. I mean, we don't have to do that, but going from small to bigger here normally is a good way to think. And then we have f of t dt. So we're going to measure the area under the curve of f from 1 to 2, and then we're going to negate the answer. And that's going to be my slope. So from 1 to 2, so we're going to be looking at this trapezoid, okay? It looks like that. Okay? And we'll put the negative out front already, so we're going to have negative, and then we have 1/2. And then the sum of the bases are my two vertical line segments, one here being a height of 2 and the second one being a height of 4. So we're going to have 2 plus 6. And so 1/2 the base times the height. In this case, the height is the actual width of the base here, which is from 1 to 2, so it's 1. So it looks like I have, whoops, this should be a 4. Let me fix that. And then we should have then a slope of -3. Putting this all together, we have a ordered pair, and that would be our 1, -3. So we have y plus 3. And then we do have our slope found to be 2, and that's going to be multiplied by x minus 1. And there's my tangent line in point slope form. And the last part of this question is we're trying to find the values between 0 and 10 that g of x has its absolute max. So what we're going to do is remember that absolute maxes can occur only in 2 places. One would be at the endpoints. So we need to check g of 0, because that's an endpoint, and we also need to check g of 10. Okay, so we have endpoints and we need to look at critical points. So the critical point of g, well, critical point of g is when g prime is equal to 0. But we recall that g prime is equal to f, so we need when the function has a height of 0. And so in that case, we need then the number 8. So now we're going to look at g of 8. And all we want to do right here is we want to measure all 3 of these based on the rule that we have up here. And so let's do that. Let's go from 2 to 0. Well, 2 to 0 under f can be written as a -0 to 2. Let's try that instead. Okay, under f. And so from 0 to 2, we're talking about this triangular region. And so we have -1/2 the base. The base is 2 and the height's 4. So it looks like I have a -4 as the value. We also need to check g of 10. We'll do that one last, because we can just take g of 8 and add that last piece. Let's find g of 8. G of 8 is measured from the lower limit 2. So this is g of 8. Let me establish that, g of 8. And this one here, I guess we'll call, this was g of 0. G of 8 is going to go from 2 to 8 under f. So we're going to be looking at this going from 2 to 8. So we have this region that is, I guess we're going to say it's going to be this region here plus this triangle. So we have that. We're going to find this middle part first. We're first going to say that we could represent this as basically a 4x4, right? A 4x4 square, and then we're going to remove a semicircle out of it. So a 4x4 square gives me 16, and then minus, and then this semicircle would have an area that we need to take away would be 1/2 pi r squared. 1/2 pi, it looks like the radius is 2, so we're going to have half of 4 pi, which is 2 pi. How about 16 minus 2 pi? And then we need to add in our triangle. So this part, 16 minus 2 pi, is just from 2 to 6. And then we're going to go from 6 to 8. And that's going to give me 1/2 base times height, kind of like the triangle that was over here. So we're going to add an additional 4. So it looks like we have a value then of g of 8 to be 20 minus 2 pi. Lastly, we need to find g of 10. Well, g of 10 is going to be g of 8 integral plus the integral from 8 to 10, which is going to be a negative number, so it's going to be smaller. So my g of 10 is going to equal my g of 8 number, which obviously is my 20 minus 2 pi, and then we're going to subtract that triangle, or subtract 4. So we end up with, looks like 16 minus 2 pi. So 20 minus 2 pi, 16 minus 2 pi, or we have a value of negative 4. Those are the only 3 numbers that we need to consider. And of course, 20 minus 2 pi is bigger than 16 minus 2 pi. So my absolute max occurs at the number 8.